All right, so yesterday we were talking about transformations. We will do a quick review to see where we're at. I don't think this should be very difficult. Maybe it'll take us 20, 30 minutes. So let's jump into some of these questions. So let's look at this function here. What type of a function do we have here? What's the parent function? It's square root, yeah? You see the root?
Mm-hmm.
It's not a quadratic. The one on the outside, that's gonna be your function. For example, if you have e to the sine x, your function is actually e to the x. It's an exponential function. The bigger picture counts. So here we have a root function. So we know the parent function root x looks like this, right? So now we gotta deduce how did we get from here to here? There's two ways to do this. I think transformation is not going to work for this question because we don't have a transformation that squares our variable. Here, x becomes x squared. So the transformation approach that we were trying to use yesterday is not going to work for this specific question. So what we're going to do is we're going to use the idea of square roots. Forget about the square root. So if we forget about that, we just get 36 minus x squared. Now think about a square root. Can you have a negative number in there? No, you cannot have a negative number in there. Can you have a zero in there? It's a square root of zero. Square root of zero is simply zero, okay? So in a square root function, I'm talking about root x, you can also see from the plot of root x that the domain is x has to be greater than equal to zero. Do you agree with this?
Mm-hmm.
Now, that same principle is going to apply to this question. Inside of the square root, this bit, right now we have x, but that bit cannot be negative. It also cannot, it can be zero, but it just can't be negative. So now we have an inequality here. 36 minus x squared is greater than equal to zero. See that? So the hardest part here is this bit. Where does this come from? This comes from the fact that you cannot have a negative number inside the square root. So now the next thing is, how do we solve this inequality? The best way, in my opinion, to solve a gra what is this, quadratic. For a quadratic inequality, inequality is because of this sign here. It's not equal to zero. If it was equal to zero, it would be much easier. To solve a quadratic inequality, if possible, graph it. That's the best way. So here we're going to graph 36 minus x squared, okay? Now we know what this looks like. This is not terribly difficult to graph. X squared, the parent function, looks like this. Now if you do minus x squared, it looks like this. And if you add 36, it looks like this. So it's an upside down quadratic function with a y-intercept at 36. So 36. Now we have the y-intercept. What do you think the x-intercept is for this? 36 minus x squared. It's 6. Okay, just the square root. You can solve it here. 36 minus x squared equals 0. X squared equals 36. X equals plus minus 6. So the x-intercepts are positive 6 and negative 6. Now, what are we interested in? We're interested in seeing when this curve is greater than or equal to 0. So we're strictly concerned from here, where the function is positive, up until here where the function is positive. Why? Because greater than or equal to 0. So we're strictly concerned with this section. So what's the answer? When is this function positive? Between which x values?
Like -6 and 6.
Exactly. So that's going to be the answer to this. Okay. So the answer to this is going to be between -6, x, 6. Cool. Now you can check your answer, right? So let's say I plug in a 7 there. So 36 minus 7 squared, that's going to give me a negative. So 7 is not good. What about 5? Is 5 good? 5 is good. Yeah, so we're good. You can just put in a couple of numbers in here to see whether or not this is true or not. Turns out it is true. So that's how you can deduce the domain of a function. Okay? Transformation is not always going to work. Let's look at this next question. It says, what is the range of the function given by the following graph? Okay, this one's actually quite simple. What's the range of this? You just look at the y values on the plot. So you can let's look at the top section first. So here, what's the range?
X has to be greater than 0.
Y has to be greater than 0. What about down here?
R has to be less than 3.
Can it be equal to -3 or no?
Yes.
Yes. So you have this here, you have this here. So what you need to do now is you need to combine them. So you can say, let me see. In set notation, you can say, curly bracket y is an element of all real numbers. Y has to be greater than 0 and y has to be less than -3. So that would be in set notation. In interval notation, you don't write YER or stuff like that. So in an interval notation, -infinity to -3. -3 is inclusive. So you have a square bracket there. Union is basically the end of interval notation. And on the other side, we have, how would you write this in interval notation? Say I wrote this like this. How would you write y is greater than 0 in interval notation? Hint, you have to use infinities. It's just like a number line, right? So y is greater than 0. What does that mean? 0 is here. You have an open circle. And y is greater there. You're going this way. So it's basically just from 0 to positive infinity. And neither one of them is inclusive. And there you go. That's the answer to this question. Did this make sense?
Yeah.
Are you comfortable with set notation and interval notation? It's not that bad. You just this is the more preferred one. I like this better because it's just less text. And you'll see it in books as well, and usually in this notation. Determine the equation that describes the following function rule. The sum of the input and twice the output is 12. Okay, let's say input is x. Let's say output is f of x. So what does this say? It says the sum of the input, so x, plus twice the output, 2 times f of x. Again, this is the output, and this is the input. That is equals to 12. I feel like this question has many answers. That should be one of them. We could also probably write x plus 2y equals 12, where y is the output. But it says function rule, so that's why I wrote it in function notation with f of x and not with a y. Cool? This is more of a whatever question. It's not super important. Let's look at the next one. The next one is important. Determine whether this function is even, odd, or neither. How do we distinguish whether or not a function is odd or even? Do you remember? What is an even function? No? Okay, let's do a quick recap of odd functions and even functions. I'll start with even. Even is easier to understand. Even function is something that's symmetrical around the y-axis. For example, x squared is an even function because whatever you have on the left side of the y-axis, you have the exact same thing on the right side. Another example of an even function is sine x. Sorry, not sine x, cosine x. Goes through 1, looks like this. That is cosine of x. And again, whatever you have on the left-hand side of the y-axis, you have the exact same thing on the right-hand side. So that's an even function. An odd function is symmetrical. This is a little bit trickier to understand. It's symmetrical around the origin. So instead of flipping it using this as your mirror, we use the origin as a mirror. It's a little bit difficult to understand. Let me give you some examples. A good example of an odd function is simply y equals x. Whatever you have in Q1, it's reflected in Q3. And if you have something in Q2, quadrant 2, it's reflected in quadrant 4. Another example is just x cubed. Positive, negative, both work. So this one is negative x cubed, but Q2 is equals Q4. It's symmetrical around the origin. So that's an example of an odd function. You remember this? So now this is from a graphical standpoint. I don't feel like graphing this, so we're not going to use the graphical approach to answer this. The other approach is the algebraic approach, which says an even function, okay, for an even function, if you plug in f of negative x, you should get the original function f of x. Whereas for an odd function, the algebraic rule is that if you plug f of negative x, the negative attached to the x comes all the way outside and you get negative f of x. So this rule and this rule, very important. And you're going to need this to answer this question. I guess you could also graph it if you know how to graph cubic functions, but that's a waste of time. So anytime a question asks you, is this function odd, even, or neither, what you should do is just plug in f of negative x. So let me show you. So here the question's given us f of x. That's x cubed plus 3x squared plus 1. So every single time what we're gonna do is you're just gonna straight up plug f of negative x. What's gonna be f of negative x here? And remember how to do this? All you gotta do is replace wherever you see an x, you just gotta replace that with whatever you have in the bracket. There's an x here, there's an x here. All you gotta do is replace those with what you have in this bracket, which is negative x. So it's gonna look like this. So that x becomes negative x cubed plus this other x also becomes negative x squared. So then you open the brackets. What's negative x cubed?
It's just negative x
It's just negative x cubed.
cubed.
Plus this one, the negative sign disappears, plus 1. So that's what we got. Now, is this f of x? Is that what we had to begin with?
No.
No. So is the function even? No, so it's not even. So no, it's not equal to that, so it's not even. Okay, it's not even. How about, is it equals to negative f of x? So let's see what negative f of x is. So negative f of x is just this entire thing multiplied by negative 1. So negative f of x would be negative x cubed minus 3x squared minus 1. Is this thing negative f of x? No, it's not. So is this function odd? No, it's not. No, it's not. It should have been equals to this if it was odd. Okay. Look at this. This thing and this thing, they're not equal. Okay. So no, they're not equal. So it's not odd either. If this was equal to f of x, it would have been even. If this was equal to negative f of x, it would have been odd. Right now, it's equals to neither. So this function is neither odd nor even. Okay. Did that make sense or no?
It did.
Okay, so what about the degree of this polynomial? Is this odd degree polynomial or even degree polynomial? It's an odd degree polynomial. So the degree doesn't have anything to do with it being an odd function or an even function. They mean completely different things. So this topic is very important. Odd, even. Let's look at this next one. 2 comma negative 7 is a point on the graph of f of x. Find the corresponding point on the graph of this transform function. All right, what type of a parent function do we have here? What's the parent function?
It's just a linear function.
Okay, why is it linear? Because you saw the x. So no, this is not a linear function. That was a trick question. We don't know what this function is. Okay? We have no idea what this function is. It could be linear, but it could also be anything. This f means it can be anything, right? Like, let me show you. So we don't know what the parent function is, but this one, if the parent function was 2 power x, your function would be 3 times 2, 5x minus 1 plus 1. If your function was sine of x, it would be y equals 3 times sine 5x minus 1 plus 1. You see that? Log of x, y equals 3 log 5x minus 1 plus 1. So this doesn't tell you the function. This does, but we don't know what it is. So in this question, we have no idea what the parent function is. But that doesn't really matter. All we're asked is we have this point on the parent function. What is this point going to be in the transform function? All right. How do we do this? Yeah, we use the point mapping. So this is very simple here. What's A?
3,
What's K?
5,
What's D?
1.
C is also 1. So you have X over K plus D, AY plus C, right?
Mhm.
So we had the original points 2, -7. So all we gotta do is plug 2 in here. So 2 over 5 plus 1. So what's that? 7/5. So that's the X value. Gotta plug -7 in here. That'll be -21 plus 1, -20. And this is your final answer. So again, a point mapping rule, we've done it many times. It's not that difficult. The only thing to watch out for this problem is sometimes they give you this point, and sometimes they give you the original point. Yesterday's question, they gave us the transform point. How did we solve that? We did it like this. Just made it equals to that and solved for the original point. But here, you just plug it in and you're good to go. Okay, state the parent function of the equation and the transformations that were applied. All right, this is a 10-second question worth 3 points. It's quite simple as well. What's the parent function? Okay, what are the transformations that were applied? What's AKDC? Let's start there. For this function, what's AKDC? Is A1 or is A3? For root function, it looks like this. A times K X minus D plus C. What's the A value for this question? Yeah, A is 3. What about K? K is 1. What about D?
-2.
Yeah, and C is 1. So now look at this, it's very simple. What does A equals 3? What does this do?
Since vertical stretch.
Yeah, it's a vertical stretch by a factor of 3. K equals to 1 does nothing. D equals to -2 means it moves 2 units to the left. C equals 1 means it moves 1 unit up. And you're done. It's very simple. You see this, right?
Mhm.
So the only thing to watch out here is that make sure your function is in this format. I showed you yesterday, sometimes the D value, they trick you. In this case, the K value was 1, so it didn't really matter. So that's one thing to watch out for. Make sure it's in the right format. And the next thing to watch out for is that the transformations, the order matters, okay? What you do matters. You're always gonna be, if you're in this form, okay, you're always gonna be doing these guys, which are what? Stretches, compressions, depending on whether it's more than one, less than one. Stretches, compressions, and the last thing was what? Reflections. A and K dictate this, right? If K is negative, then it's a reflection on the y-axis. If A is negative, it's a reflection on the x-axis. You're always going to be doing these three, okay, in any order. The order here doesn't matter, but you have to do these before you do translations. Okay? And it comes from the BEDMAS rule. You multiply before you add or subtract. Translation, you're always adding or subtracting. stretches, compressions, you're always multiplying. So you're always going to do those first, and then you're going to do the translation. If you're coming at it from this form, which we will always be coming at it from this form. Okay, let's look at this one. Given f of x is root x, find the domain. All right, how do we do this one? What's our plan of attack? We have a root function, and we're asked to find its domain. No? Okay, why don't we first come up with the equation? Let's come up with the equation. What's AKDC here? This one's very simple. Or is it? I guess we'll see. What's AKDC for this question?
K is 7.
Yeah?
K is 4. E is -2. C is -2.
So, again, remember, they're going to trick you. This is a trick question. K is not 4. D is not -2. Let's try that again. What's K? Is it 4 or is it -4?
-4.
Yeah, so if you pull that negative sign out, K becomes -4. And now look at this. This becomes -2, -2. So what's your D value?
2.
2. Yeah, it's a shift to the right, not to the left. You see that, right?
Mm-hmm.
All right, so this question's asking us for the domain, okay? So here's the thing about domain and ranges. Domain and ranges, they're unaffected by compressions and stretches. Unaffected by stretches and compressions. But they are affected by reflections and translations. So left, right, up, down affects it, and reflection affects it. So you see this A7? Does this affect the domain in any way? No, it does not. So you can ignore this. K equals -4. The minus sign is important. This is important. This is important. The 4, you can ignore the 4 too if you want. And just treat as K is -1. All right. So let's see what the domain for this is going to be. I'm going to sketch this using transformations. The parent function is root x. Looks like this. Our first transformation is a reflection on the y-axis because K is negative. It's -4, but it's negative, so we're going here. K is negative. And then we're going 2 units to the right. So we're here because of this. And then we're going 2 units down. So the final curve will look like this. It's going to start at -2 down there, and it'll go like this. Okay? So this starting point is 2, -2. That's also called, I'm going to call this, I don't know if this is technically correct. I'm going to call it the boundary value, which is like the starting point. Okay. The starting point tells you the domain. It also tells you the range. You also got to look at the direction where the curve is headed. What is the domain of this function? And look at this sketch here. What's the domain?
X has to be less than 2.
Can it be exactly 2?
Yes.
Yes. So look at this. I'm going to use interval notation. The domain, it can be anything from -∞ to +2. Rounded on infinities. Infinities are always exclusive. Rounded means it's exclusive. And a square bracket on the 2 because it's inclusive. What about the range? What's the range for this?
Equals and greater than -2.
Perfect, yes. So for the range, we write -2 to positive infinity. And -2 is inclusive. There we go. It's always lower value when you're doing interval notation. It's always lower value on the left and the higher value on the right. If you write infinity and -2, that doesn't make sense, okay? Because infinity is not less than -2. It's a very common mistake though, but you will lose points if you write it like this. It's always lower and then higher. Yeah, let's look at this one. What's this parent function? What is that called?
An absolute value function.
Yes. So it's compressed horizontally by a factor of 2, reflected across the y-axis, and translated vertically downward by 8 units. Determine the equation. All right. So basically what we have to do here is they've given us transformations in wording, and we have to translate that into mathematical AKDCs. It's not terribly difficult. So let's see. Compressed horizontally by a factor of 2. Is that A or K?
Okay.
So is K 2 or is it K 1/2?
Yep.
K is 2, okay? Remember, K is the opposite, so if K is 2, then that's a compression by a factor of 2 or by a factor of 1/2, all right? Reflected across the y-axis. What about the next part? What does this mean?
K is negative.
Yes, K is negative. And translated vertically downwards by 8 units. What is that?
C is -8.
C is -8, yes. So that means D is 0 and A is 1. A cannot be 0, okay? A is 1. So that doesn't affect it. That doesn't affect it. We can ignore that. Okay, cool. So the equation for this is going to be, well, A is 1, so you can write 1 or not write anything, times K, X minus D, you can write just X or X minus 0, plus C. And there you go. That's the equation. It's literally just -2x minus 8. Cool? So let's see what that looks like. And we'll come up with the domain and range for that. So absolute value function looks like this, looks like a V. What did we do? We compressed it horizontally and shifted upside down. Vertical compression, well, sorry, horizontal compression, what that does is it compresses it inward. So it becomes like thinner. Like that. And then it's also reflected upside down. So it becomes thinner and then it's reflected upside down. So like that. And then after this, sorry, it's not reflected upside down, my bad. It's reflected on the y-axis. So it's reflected from left to right. So it'll still look like this. And then after the reflection on the y-axis, it's going down 8 units. So the final curve is going to look like this. This point is -8. It's on the y-axis. What's the domain of this function? What's the range of this function?
Domain is XCR.
Domain is XCR, yeah. What about the range?
It has to be greater than -8.
Yes. And you're done. Easy peasy. X here in an interval notation, you would write -infinity to +infinity. What type of a function do we have here?
It says piecewise.
It's piecewise, yeah. What does piecewise function mean? It's basically just a combination of multiple smaller functions. Okay?
Mm.
It says sketch this. All right. So, do you think this is going to be difficult? If you look at the functions, you have two linear functions. How hard could this possibly be? This is like a 30-second question. It's worth 4 points. C means communication. So let's see how we can sketch this. I'm going to draw a grid and then we will start with the top equation. So the top equation is x plus 5, which means the slope is 1, the y-intercept is 5. Very basic. So let's go find both of those. So 1, 2, 3, 4, 5. We have the y-intercept and the slope is 1. So for every 1 unit it goes up, it goes 1 unit across. So we have another point. Now this function, the top function, is valid only between -5 to 0 on the x-axis. So that means -5 to 0. Let me just draw this line. So to draw a linear line, you just connect 2 points. So this is the top function, okay? With the piecewise function, what you need to do is you need to erase portions of it. So this function only exists between the x value of -5, so 1, 2, 3, 4, 5, to the x value of 0. So what I'm going to do is I'm going to erase everything else because this function doesn't exist beyond 0 or beyond -5. So there you go. That's the sketch of the top function. Now the bottom function is only valid from 0 to 4. For the bottom function, what's the y-intercept?
It's 5.
It's 5. So again, we're starting at the same point, but now the slope is -1/2. So that means for every 1 unit we go down, we go 2 units across. That I got this point by using the slope of -1/2. Now, like we did before, to graph a linear function, all you need is 2 dots. So that's the second function. But the second function is only valid from 0 to 4 on the x-axis. So from 0 to 4. So what we're going to do is we're going to erase everything else. And there you go. Final answer. You're done. One thing though you need to keep in mind is the idea of open circle and closed circle. Here both -5 and 4, the n bits, are inclusive. So what we're gonna do is we're gonna put closed circles there. There you go. And that's the final answer. So it's quite simple because you're just graphing linear functions. Graphing linear function is grade 9, 10. Is this function continuous? On top
No.
of it's not continuous. Where is it? Where is it discontinuous? At which x value is the function discontinuous? No, this function is continuous, okay? Continuous means there's no holes, there's no breaks, there's no jumps, there's no asymptotes. Only those things make a function discontinuous. This function, we start here, you can just write this all the way to the end. This function is continuous on its domain. All right, so this is the opposite of the question that we just did. In the question we just did, they gave us equations and we sketched it. Here we're given the sketch and we need to come up with the equations. So here's something that you need to be able to do at this level. You see the quadratic at the bottom?
Mm-hmm.
What's the equation of that quadratic? Look at the x-intercept, look at the y-intercept. What do you think is the equation for that quadratic? No? It doesn't give it away. Plus minus 2 are the x-intercepts. The y-intercept is 4. So look at this. It's x squared minus 4. Okay? You see it now or no?
Mm-hmm.
That one is x. They're not going to give you a complicated transformation thing in a piecewise function question. It's always going to be x squared plus something or minus something. Worst case, they might give you like 2x squared minus 4 or something. This is as far as they're going to go. They're not going to go like x minus 3 squared plus 4. They're not going to go this deep. Usually, though, it's like this. It's just x squared minus or plus something. So we already know the equation of the middle guy. So let's write this down. So f of x is equals to, it's made up of 3 different functions. The top one is valid from -4 to -2 inclusive. So -4 is exclusive, 2 is inclusive. The next function is valid from -2 to 2, exclusive on both ends. The third function is valid from 2 inclusive to 4 exclusive. Like that. And what did we just deduce? We deduced that the quadratic is x squared minus 4. Okay, now let's deduce for these two guys. For these two guys, the slope is the same, but it's the opposite. One of them will be positive, one of them will be negative. What you can do is you can actually cheat. Check this out. It's not cheating, this is just being smart. What's the y-intercept for both of those linear functions?
0.
0. So we know they don't have y-intercept, so all we're concerned about is the slope. The slope is 2 units across, 2 units up. Same thing here. So the slope is 1. Yeah? So the top function, the slope is going to be -1. So negative x. I'm just doing y equals mx plus b. b 0. The y-intercept is 0. The slope is 1. -1 for this guy, +1 for this guy. And there you go. That's the final answer. 3 equations, 3 ranges for 1 f of x. It's a piecewise function. All right, is this function discontinuous or is it continuous?
Discontinuous.
Where?
X is -2, 2.
Yes. What type of a discontinuity do you have? It's called a jump, okay? Because you were here, right? And then you randomly teleported here. Teleporting is called jump discontinuity. That would be relevant in the calc course, not so much for the functions at course. All right, let's look at this. It's a boring question. Not gonna bother with that. Not gonna bother with this either. It's just a simple point mapping rule. And maybe we do this one. That one looks pretty simple too. This one looks interesting. It's worth 6 points. All right. So we're given an equation f of x. It's a quadratic. Okay, cool. Part A, find the ordered pair 6 f of 6 on the function. All right, what does that mean? It just means find the x and the y value at 6. And well, the x value is 6. So for part A, all you have to do is this. F of 6 is going to be equals to 4. 6 minus 3 squared minus 1. 4 times 3 squared minus 1. 35. So therefore, the answer to part A is 6, 35. And you are done. Easy. Yeah?
Mhm.
Part B, find the ordered pair on the inverse relation that corresponds to the ordered pair from part A. So how are points related from a parent function to the inverse function? What happens to the point? It flips. Y becomes X, X becomes Y. You remember that? Interchanging the variable, yeah? So if the answer to A is 635, 6 comma 35, what do you think the answer to B is?
35, almost like.
Yeah, easy peasy, 35 comma 6. Okay, part C. Find the domain and range of f. So f is the quadratic. What's the domain of a quadratic function?
XER.
XER. What about the range? Which form of the quadratic is this in? Remember, quadratic has 3 forms. Standard form tells you the y-intercept. Factored form tells you the x-intercept, and there's a third form. What is the third form called?
The vertex form.
And it tells you the vertex. Where's the vertex for this quadratic? This is the form. X minus h squared plus k, where hk is the vertex. So if you compare this with this, what's h, what's k?
3 and -1.
3 and -1. So your vertex is at 3 and -1, right? Is this parabola opening up or down?
Up.
It's opening up. So you have a vertex at 3 and -1. We don't really care about the x-intercept. And the function is opening up. So what's the range of this quadratic?
Y has to be greater than or equals to -1.
Perfect, yes. Okay, that's part C, the domain and range of a quadratic. Very simple question. Part D, find the domain and range of the inverse. So inverse functions, they're just points. In terms of points, x becomes y, y becomes x. Very simple. In terms of domain and range, it's the same idea. The domain becomes the range, and the range becomes the domain. So for the inverse function, what is the domain? And the hint is that it comes from part C.
X has to be greater than or equals to -1.
Yeah. What about the range?
YER.
YER, exactly. So that's part D, very simple. Always use the parent function to answer these questions. There is another way you can do this, which I don't recommend. The other way of doing this is that you come up with the equation. Let's first kill part E and then I'll show you the other way. Is the inverse relation a function? All right, so you probably forgot about this. So to see whether or not the inverse is a function, okay, talking about the inverse, what you do is on the parent function, on f of x, on the original function, you do a horizontal line test. We've done vertical line test. That tells you whether f is a function. But to see whether f inverse is a function, we do horizontal line test. The concept is the same. If it crosses the curve twice, that's a fail. So you see here, this is a horizontal line. It crosses it twice. So what does that mean? That means f inverse is not a function. Cool? This is the easiest way to see whether or not the inverse is a function is by doing a horizontal line test. Okay, let's assume there's a part f, and the part f says find the equation for f inverse. So let's do that. To find the equation algebraically, step number one is interchange the variables. I'm just going to call f of x as y for now. So what we're going to do to find f inverse is y becomes x and x becomes y. So check this out. X equals 4, y minus 3 squared minus 1. How do we solve this equation for y? We need to isolate y.
You add 1.
Okay, let's add 1. What's next?
You divide by 4.
Okay, you divide by 4. What's next?
You square root.
Okay, you square root it. At this level, remember, whenever you square root, it's always going to be plus minus. What's the last step?
You add 3.
You add 3. So there you go. That's the equation of f inverse. So what I said earlier was you always want to do the domain and range using f and not f inverse, because look at this. It may not be easy for you to find the domain and range of that function. What does that even look like? So this one, let's write it like this. 1 over 4 x plus 4 plus minus, looks like that. So it goes left 4 units and then goes 3 units up and 3 units down. Okay, so I think it looks like 3 units up. We had the vertex here, didn't we? The vertex was 3 and -1. That means the vertex for this guy is going to be at -1 and 3. So that's what I was trying to find here. -1 is here, 3 is here. So this is a vertex. And the square root function, it has two ends. Positive because of the plus and negative because of the minus. And there you go. And if you do a vertical line test on this, you see that it fails. So f inverse is not a function. You can also do it this way. But this is definitely an important question. Finding the inverse of a quadratic algebraically. All right, cool. Let's call it there for today.
Okay, thank you.
See ya.